let's start with the another concept, right? So just give me a second. So the next part which we are going to start over here is let's make it a new document. Okay. So the next thing or the next concept which we are going to start right now is EBS. EBS stands for Elastic Block Storage or Elastic Block Store, right? This is some kind of a network drive which you can attach to the respective instance, right? So we'll write it out, network drive. That means which you can attach or detach to the respective EC2 instances, right? That means let's say if you have any in the normal computer, let's say if you have attached one pen drive on one respective hard disk on our local machine or local laptop, physical laptop, right? That means this is something which is similar, but this is a network drive, not a physical drive, right? Remember one thing: these respective network drives or the EBS volumes are bound to a specific availability zones only. Okay, not specific region even. They are bound to specific availability zones, right? They are some kind of a network USB stick, right? So according to the AWS Free tier, the 30 GB of EBS storage of type general purpose SSD is free. 30 GB general purpose SSD is free, right? Remember one thing. Another common interview question: are the EBS volume bound to specific availability zones? Yes or no? The answer is yes. They are bound to specific availability zone only, right? Moving ahead, this remember one thing: this is the complete network drive, not a physical drive. That means it uses a network to communicate between the respective instances. So a little bit of latency can be observed, right? You can configure the respective EBS volumes according to the use cases. That means the size in GBs or input outputs or whatever the respective use case is, right? So let's understand this thing right now. So let's say if we have one availability zone, let's say US East 1A over here. Let's say we have another availability zone, let's say US East 1B. Let's say AZ1, right? Or let's say AZ2, let's say. Okay. So what let's say if we have one EC2 instance over here, another EC2 instance over here, right? This is an EC2 instance, EC2 instance 1, whatever you can think of, is another EC2, right? And we have one more EC2 over here as well, right? Okay. So the thing is, let's say if we have one EBS volume over here, this is one volume, let's say this is another volume, and this is another volume. Okay, and let's say we have one and two volumes over here. So what we can do is we can attach one EBS volume to this. We can attach one respective EBS volume to this, and we can also attach two volumes to respective EC2 instance as well. And we will see this thing in the hands-on as well. And we can attach this respective EBS volume to this, and we can also have some unattached EBS volumes as well. Right? Remember this thing that these are some kind of a let's say virtual pen drives, something like that. But this is completely reliable on network, right? So some type of latency can be observed, right? So this is the thing which we need to remember, right? So let's directly move towards the hands-on to see some new concepts like delete on termination and the snapshots and everything. So let's say if you need to, as I said, the respective EBS volumes are bound to a specific availability zone only. Let's say in the Mumbai, we have three availability zones. So if let's say 1, 2, 3, so you have created an EBS volume in availability zone 1, right? So this respective EBS volume will not be available in these respective different availability zones. So for this thing, you need to take a snapshot of the respective EBS volume, and that respective snapshot can be available in the different you know availability zone, right? So this is the thing which we can see in the hands-on. So if we directly go towards the the EC2, the EBS volumes. Just a second. Elastic Block Store, we can see volumes over here. As of now, there are no specific volumes available in this region. So let's launch an EC2 instance, and I'll show you one concept that is known as delete on termination as well. Right. So these respective instances are terminated. Let's create a new instance. Let's say my 7th instance. Okay. Go down. Amazon Linux 2, T2 Micro, so the same things. And let's launch this in Mumbai. Right now in Mumbai. So AP South 1A I'm choosing, right? The respective availability zone, security group. I said we don't need that. So let's select the respective security group because we're not going to associate into this respective instance, right? So instance is G. Okay. So if we can see the in storage, click on advanced, right? So volume, this respective volume is attached. Remember this thing, delete on termination, this is yes. Okay. That means whenever this respective instance is terminated, the respective volume will be deleted as well. If you have some data available in the volume, what you can do is you can just click on no. That means the respective volume will not be deleted after the respective instance is terminated. Right? So this is the thing. So if we can just launch an instance, okay, we don't need any specific key pair, but let's give something first. Launch instance. This instance is now launching. We can see, let's open the respective instance. Okay, the instance is now launched over here, right? So if we can just select the instance state equals to running, we can see this respective instance is running, right? So click on this, right? So click on storage. You can see we have attached one block device. It is the device name is this, volume size is this, which is attached, and delete on termination is set to yes, right? So this is the thing, and let's move ahead with this volume ID. Click on this volume ID, and you will be redirected towards this respective volume. You can see this respective volume is available and this is in use. You can click on this. You will get some more details. This volume is in use, size of 8 GB, type GP2, and everything. Right? So let's create a new volume and attach to our running AWS EC2 instance. Click on create volume. Right? So let's create a volume of, let's say, 2 GIB. Okay. Scroll down and create the volume. The respective volume is now created. Click on this. As you can see, this is now creating. Refresh this page. Okay, this respective volume is available now, right? So what you need to do is you just need to attach. You can attach this respective volume to the running EC2 instance. Right? So click on actions. Click on attach volume instance. Okay, so you can see this respective instance is on running. Okay, so the device name will be this attach volume. Okay, so as you can see, this respective instance, this respective volume, which is available in AP South 1A, right, is attached into the respective running instance. Right. If I just go towards the instance, click on this, and storage, go down, you can see the respective block device, new device is attached, and the deletion on termination is no. If I just launch a new instance in AP South 1B, right, and if I'll just use the respective new EBS volume to attach in AP South 1A, that is not possible because that respective instance will not be cached up, because as I've already explained that the respective EBS volumes are available in the respective AZ or availability zones only, right? So as I said, if you need to move the respective instances, or sorry, the EBS volumes across different availability zones or different AZs, you need to take a snapshot. So if I just go towards the volumes here again, right? And let's say if I'll just click on actions, right? So let's create a new volume, right? So let's say 4J. Okay, I'm just creating an AP South 1A, right? Create the volume. Okay, this 4 GIB respective volume is available. So this is the power of cloud. If I just ask the respective volume or the space or anything, the cloud can give us, right? So this is the thing. So if I can just refresh this page, this respective volume is 100% available, right? Click on this. So if you need to move, or let's say if you need to just use this respective volume to be available in different availability zone. So click on actions. You need to create the snapshot, right? Create the snapshot, right? The respective snapshot. Let's say new snapshot. To create the snapshot. The snapshot is now created. So head over to this snapshot section. You can see this respective snapshot is now available, and this is in the completed state. This is available 100%, right? So we can click on right click on this, right? If you can click on copy snapshot, remember this thing, copy snapshot. You can see using the copy snapshot, you can move the respective volume across the regions. Remember this thing. Using the copy snapshot option, you can move the respective EBS volume to different region. I'm not talking about availability zone, region. Okay, if I just cancel this, I can just copy this and actions. I can create a volume from this snapshot, create a volume. So I can see, I can move this respective, I can just take the snapshot, use this respective snapshot to create a volume in different availability zone of the Mumbai region. I hope the things are getting synced up. I'm just explaining you this thing one more time. I have created the respective snapshot of the 4GIB volume, EBS volume. Okay. If I need to move this respective EBS volume to different region, let's say I want, let's say just a backup of my data in different region. What I can do is I can just click on right click and copy snapshot. Using the copy snapshot, I can uh, move or copy my data to different available, sorry, to different region as well. I can encrypt the snapshot as well. So if I can cancel this, and to move across AZ, click on this, select this respective EBS volume, actions, and create volume from this snapshot. And here you can see I can move the respective EBS volume to different availability zone as well, right? So this is the thing which you can try this at your end. So this is very handy, right? So this is the thing which we can check this out. So if you go towards the instances, you can see seventh instance is now running. So if I can go towards the storage and delete automation, yes, that means the root volume will be deleted after the instance will be deleted. So if I can just click on instance state and terminate the instance and terminate, let's see what will happen. Refresh. So you can see the instance is now shutting down. Okay. Okay, the instance is not terminated. If I just head up towards the volumes, I can see only two volumes. The root volume of that respective instance was gone. As the respective instance was gone, the EBS volume was also gone. Right. So here, these respective two volumes are available, which are not even attached to the respective instance. I have attached a 2 GB of instance, 2 GB of respective EBS volume to the running instance. As the instance is now gone and the delete on termination was no for this respective EBS volume, and hence this EBS volume is persisted in the AWS account. So just to save the cost, I'm going to delete these respective EBS volumes, delete volume, and I delete. Okay, so now I hope the things are making sense over here, right? So the things are setting up over here. So The EBS thing is not that much deep. So I think the only uh, concept which you need to remember is regarding the uh, availability of the respective EBS volumes. That means the respective EBS volumes are available in the specific AZ only. That means you can move the respective EBS volumes, right, between different availability zones using the snapshot feature, as we have already seen in the respective hands-on. But if you need to move the respective uh, EBS volumes to any different region, let's say if you're in the Mumbai region, I need to move the respective EBS volume to any other region, you need to copy the respective EBS volume to different region only, right? So this is the common interview question, as well as this question may be appeared in the AWS certified solutions architect as well in the respective exam, right? So this is the common thing which you can check on, right? So let's move ahead with the newer concept, that means the AWS Elastic Load Balancer, right? So load balancer thing is very common. That means different types of load balancers are available in the market. I hope you heard the names for the, let's say, HA proxy or something like that, or Nginx or something, right? Those respective load balancers are available in the market. So in the HA proxy, you need to configure the load balancer accordingly. You need to modify, right? Or let's say if you need to create the respective configuration file, right? Let's say the file that is known as haproxy.cfg or something like that, you need to configure each and every bit, right? And accordingly, you can configure the load. That, let's say, different algorithms are available. Let's say to balance the load. Let's say the round robin algorithm and different algorithms are available. But that respective thing is, maybe sometimes hard to configure, right? So that is the thing which maybe sometimes pain in the neck, right? But that is also can be helpful when you need some configuration which is completely according to the use case, which is not fulfilled by some managed load balancer. But if you just consider the managed load balancer provided by the cloud, so we can use something that is known as elastic load balancer. What is the name of load balancer natively? We will see this that thing in just a second. But let's say if we have something which is left in this console, so we can terminate. The thing is left. Okay. One thing is still left. AMIs. Okay. So AMIs, as we've already understood that the AMI stands for Amazon Machine Image, right? But remember one thing, we can also create our own AMI as well, right? So our own AMI, that means we can how we can create our own AMI. That means, let's say if we need to launch an EC2 instance first. Let's say if we have launched an EC2 instance, right? And we have installed some different softwares. Let's say if we have installed HTTPD, PHP, or whatever the configurations we can do, right? And with this respective configuration, we can create an AMI. And after this, we can launch the our own machine by using our own custom AMI as well. And this is the business on the AWS Cloud as well. There is something that is known as AWS Marketplace, by where the different sellers are also, just performing some nice configuration. Let's say configuration of Magento, PHP, and everything in the respective AMIs, and you can buy from the respective marketplace so that you will get the configured softwares which are working in the working condition as well, right? So that means we can create our own AMI as well, right? So if I just head up towards the console, and if I can click on AMIs, I can see there are no respective AMIs which is owned by me, right? So what I can do is I can also create my own AMIs. Click on instances. Let's launch an instance, right? Let's say my eighth instance. So if I can just go down and T2 micro, keep here. Go down. So right now I'm just going to give some user data to this, right? So just to install the HTTPD on this, right? I'm just going to type the shell script again. Then bash yum update -y yum install HTTPD -y system ctl start HTTPD, and just to process the reboot, I'm enabling this as well. Okay, so let's check the spellings. Bin bash yum update -y yum install HTTPD -y and system CTL start HTTPD system CTL enable HTTPD. Right now, you can observe that I am not giving any data. That means I'm not giving any specific uh, details. That means not creating an index.html file, because obviously whoever the user will be able to will use his respective machine will get the HTTPD installed as the software pre-installed. So I can just create the AMI from this respective machine. So what I'm going to do is I'm just going to launch this respective instance here. So let's wait for this instance to get launched. Okay, this instance is now running, right? So I can click on right click on this, and I can click on image and templates, right? So what I can do is I can create an image from this, right? So after creating an image, right? So a respective brand new custom AMI will be created with the installed HTTPD software, right? So right now we have just used some bootstrap, right? So what you need to do is let's click on this, copy this, and let's open this, paste. Okay, I need to check the security group of this security group. Okay, port number 80 is allowed from everywhere. Okay, so the this is still the respective script is not yet installed. Let's wait for a second. Okay, so this is a test page by Apache. So obviously this is the basic uh, test page which is given by Apache. So I haven't created any custom page. So that is why this is the test page which is given by Apache HTTP to us, right? So with this respective uh, instance, we can create our own AMI. So if I can just right click on this, click on image and templates, create image. So let's say HTTPD AMI. I can name this image, right? I can give the description or whatever I want. I can just select a no reboot. What is the name of no reboot and everything? So this is completely out of scope. This is the more inclined towards this ops part. So I'm not covering what is the name of no reboot as well. So let's create the image. So my respective image is created. So if I can go in AMIs. So right now this is the status is pending. Let's wait. What is uh, AMI to get completely available, so that we can launch our instance with this respective our own custom AMI. Refresh this, refresh this, refresh this, and refresh the page. Okay, the status is still pending. Let's wait for another minute. Okay, the status is still pending. It can take up to 5 to 10, maybe 5 minutes. Okay. But you got the point, right? So in this thing, we can create our own custom AMI as well. So the thing over here is uh, that we can create the configuration in the respective AMI, right? On the other hand, we can just set up the different configuration in the our own custom AMI, and we can launch the respective AMIs, launch the respective EC2 instances by our own created custom AMIs as well, right? So different. If you can just click on owned by me, private images, public images. Let's click on public images. You can see different public images are available, which is available in AWS Marketplace. But let's say if we need to select for, let's say there are 59,000 public images available. Let's say we want, let's say Magento, where Magento is installed. Okay, so Aurora Magento configurations, Bitnami Magento configurations. You can see different configurations available in the AWS Marketplace. I can buy them and I can uh, work on according to my use case. So I don't know why this respective status is still pending, but you got the concept, right? So uh, let's wait for the last minute so that we can mm, sync up. This is configuring. If I go towards the instances and if I can just launch the instance, my AMI is owned by me. STDBD AMI is available over here. Okay, awesome. But why is it showing pending? Okay, okay, this is the volume. Sorry. EC2. Okay, this respective HTTPD AMI is now available, right? So if I can just go towards the launch instance and let's say my ninth instance, my instance, right? I'm just selecting my AMIs and owned by me. I'm just selecting the HTTPD AMI, right? I'm just going down. T2 micro key pair is let's say our old beloved key pair first instance security group, instance security group, right? Go down. And in the advanced details, I'm not going to install any specific software. I'm just going to do the data. So when bash, this is required for the shell script. So echo this is coming from the EC2 instance private IP dollar host name slash var slash www slash html slash index dot html, right? So I'm just creating a file. Echo, this is coming from EC2 instance with a private IP. This is a respective variable. And this is an data var HTML to index.html, right? So I think the things are completely fine. We are launching with our own custom AMI T2 micro instance. This is this launch instance. So I think you are now very much comfortable in launching the VMs in the AWS cloud, right? So let's This spreader instance is now in the pending state. Okay, this is now running. If I can click on this, copy the public IP address, new incognito tab, open. Okay, fine. Okay, so we haven't installed any kind of software or anything, but we can see this is coming from instance private IP. This. Okay. So I hope the things are very much clear. That means how you can create your own AMI and everything, right? So that this is the power of the AWS or any respective cloud, right? So we can just cancel this out and stop the respective instances and delete them so that I will not get billed for the same terminate. Okay, just please remember that terminate the respective instances when you are not using or otherwise you get billed. So let's check my AMIs over here. Click on this, actions, deregister the AMI, deregister the AMI. Okay. I also deregistered my respective AMI so that I'll not also get billed for the respective AMI available as well, right? So now let's head up towards the concept which we were discussing, that is load balancer, right? So let's say uh, we have one instance where our application is running. We have one fancy web application running. Okay, but right now remember one thing that you have created only one EC2 instance, let's say, right? So the thing over here is the people are hitting the respective IP address, or let's say if you have configured something that is known as Route 53 or DNS, let's say. So there is the people will hit the name, the respective DNS name, and that respective thing will be the request will be transferred to the EC2 instance, right? So the thing over here is right now, if the load is increasing tremendously, so there is something that is known as CPU utilization. That means the how much the resource utilization or the CPU utilization is occurring. That means how much CPU is being used by the instance. Let's say the CPU is getting 80%, 90%. That means you need to add the one more instance. Let's say you added one more, but you need to configure some additional configuration so that the traffic will be routed over here on this instance. But this is something which is hard to configure. That means you need to route the traffic or something like that, right? So the thing over here is uh, what we can do is we can just enable something that some central communication. That means let's say the traffic will hit on this central communication or one channel, right? Or one something that is known as a load balancer, which will balance the respective load across these respective instances, right? So this is much more optimal. So different load balancers are available. Let's say there's one load balancer that is known as HA proxy, high availability proxy, and Nginx, and different load balancers are available in the market, right? But if we need managed load balancer, which is provided by the AWS Cloud, right, which we can use, that means we can directly deploy the load balancer uh, in front of our EC2 instances. But before directly jumping towards the hands-on of the load balancer, I need to explain you one more concept where most of the students are still confused. There is something that is known as scalability. Scalability. And there's something that is known as high availability. Right? So the scalability simply means that means an application or system can handle greater loads by adapting. Let's say if you are just adding some n number of nodes or something towards the respective cluster, right? So obviously, let's say if you're just working on, let's say, an AWS open source cluster or something like that, obviously, let's say if the traffic is hitting on the cluster, you have added some different one or two number of nodes into the cluster, it will perform the blue-green deployment. What is the name of blue-green? Right now, we are not going to cover that. But still, you have added some amount of nodes right now to handle greater amount of load, right? So there are two types of scalability available. Remember this thing. This is also one common interview question. Two types of scalability available, something that is known as vertical scalability. Another one is known as horizontal scalability. All right. So vertical scalability and horizontal scalability. Horizontal scalability simply means elasticity. Okay. So the scalability is linked, but scalability is almost linked with the high availability, but exactly not same. So right now, I'll just clear this respective confusion, right? So let's say, so we have one person available over here. Let's say, remember this thing, okay? Let's say we have one person available over here, which is working, and let's say he can send two emails in 5 minutes. Let's say, okay, this respective person can send two emails in 5 minutes, but the load is coming, and we want something much more optimal. So let's say we have hired one more person, which can send five emails in 5 minutes. Let's say, okay, we have just optimized our work. That means we have just hired some more experienced person. That means vertical scalability simply means increasing the size of the instance. Let's say right now you're using T2.micro machine type. Okay. Now vertical scalability means that means you're shifting to T2.large, more power. Okay. Vertical scalability is very, very common for non-distributed systems such as databases. Okay. And let's say RDS or let's say if you've ever worked with Elasticache or something like that. But there is a limit. Obviously, there is a limit, that is the hardware limit on which how much you can vertically scale up. Remember this thing. Vertically scalability means changing the machine type to higher instance. T2 micro to T2 large, T2 large to T3 medium, T3 medium to T3 large, M5 large, M6 large, whatever you can think of. But obviously, there is a hardware limit. Okay, the services like relational database service, Elasticache can be scaled up vertically. Moving ahead towards the horizontal scalability. What is the meaning of horizontal scalability? This is something like that. Let's say a person over here can send two emails in 5 minutes. But right now, we have hired three more persons, let's say one, two, and three. That means they can also send two emails in 5 minutes, two emails in 5 minutes, and two emails in 5 minutes. Horizontal scalability means increasing the number of instances for your respective application. Let's say if your instance is running with two instances, you have added two more instances of the same type. This is known as horizontal scale. And this is very common for web applications or modern applications. And this is very easy to horizontal scale, and very, very thanks to AWS EC2 service. But now let's head up towards the high availability thing. What is the core concept of high availability? High availability uh, goes hand in hand, something like that, with horizontal scalability, right? So high availability simply means what? Let's say high availability means running your application in at least, let's say, two availability zones or data centers, right? That means your application is available in one AZ and another AZ as well. As I was already discussed this thing, and let's say if this respective AZ goes down, our application is available over here. The goal of high availability is to survive the data center loss or any act of God event. The high availability can be passive, let's say for RDS multi-AZ, let's say for example, if you've ever worked with RDS before. Okay, so this is the core concept of high availability. Let's again revise the concepts. Vertical scaling. Vertical scaling means let me increasing the instance size. Remember this thing, another common interview question. Vertically scaling means let's say if you have changed from, let's say, T2 micro to T3 TD medium, so you are scaling up. This is the technical terminology, scaling up or scaling down. Let's say if you have moved from T2 micro to T3 medium, you have scaled up. Let's say again T3 medium to T2 micro, you have scaled down. This is the technical terminology. Heading up towards the horizontal scaling, right? Increasing the number of instances, that is known as scaling out. Decreasing the number of instances, scaling in. If you are giving an interview, right? So this thing, please remember, scaling up means vertically scaling. Scaling out means adding instances. Out and up, down and in. Remember this thing. So this is a technical terminologies which you can use, right? So this is the thing which you can handle up in the interviews as well, right? So we have just completed almost a theoretical concept. We are just heading up towards the hands-on part. But let's understand why actually the load balancer is required. That means obviously you can spread the load across multiple available instances, right? You can obviously expose a single point of access DNS to your respective application, right? And you can seamlessly handle the failures for the downstream instances, and you can obviously health check that the respective instances are available. Let's say if the respective instances are available to handle the request or not. Provide SSL termination, stickiness, and everything which we will cover in the hands-on. So the elastic load balancer over here, ELB, right? ELB is a managed load balancer which is provided by the AWS Cloud, which guarantees that the respective load balancer will be working. AWS will take care of the upgrades, maintenance, and high availability of the respective uh, elastic load balancer. This respective elastic load balancer is connected with different AWS offerings and services like auto-scaling groups, Amazon Elastic Container Service, CloudWatch, Route 53, AWS Wrap, Global Accelerator, right? So these are the things which we are not going to cover in this, but still the things which are connected. There is something that is known as health checks. What is the meaning of health checks, right? Health checks is very crucial thing for the load balancer. Let's say there is one load balancer available over here, right? And there's one EC2 instance available over here, right? So let's say we are working for the port, sorry. Let's say if we need to check the working on a protocol, let's say HTTP, and we are just working for any XML custom port, let's say 456, whatever it is, right? Custom port, something like that. And we are checking some health at some respective point or some respective URL, right? Health check means that means the load balancer will check at the backend if the respective health is fine or not. Is the health is if the health is fine or not? If the health is fine or not? So there are some different intervals in which we need to check the health of the backend EC2 instances if they are able to respond to the respective instances or the request of the clients as well or not, right? So that is why health checks are important. We will see this thing in the hands-on part as well, right? So now let's head up towards the respective hands-on. But before directly jumping towards the hands-on, there's one more last thing which is available. There are different types of load balancers available in the AWS cloud. Types of LB. Okay, so there are four types of load balancers available in the AWS cloud. The very first load balancer available is which is deprecated classic load balancer or CLB, which is launched in 2009, which works on post protocol HTTP, HTTPS, TCP, SSL, that is known as secure TCP connection, right? So now On the other hand, we have another load balancer that is known as application load balancer ALB, which works on layer 7. Right? I'm not going to explain what is the meaning of layer 7. Obviously, if we are learning AWS, we need some networking knowledge as well. So HTTP application works on layer 7, and the protocol works with HTTP, HTTPS, and the WebSocket. On the other hand, we have third load balancer that is known as NLB, high throughput, high energy, and the low latency load balancer, which works on protocols TCP, TLS, and the UDP. Another load balancer which is introduced recently by AWS in 2020, Gateway Load Balancer, GWLB, right, which operates on layer 3, that is network layer, right? And in the end, we are not going to cover gateway load balancer in the hands-on, but we are going to see these three respective in the hands-on, because gateway load balancer is complete out of scope. But still, I will explain you what is the core concept of gateway load balancer, right? So let's see the concepts of the load balancer in the uh, hands-on, right? So let's move ahead. So let's create three instances first. So launched instance. So let's say load balancer instances. Okay, I'm going to launch three instances. Okay, E2 micro of the type and keep here first instance. Right, go down. Security group, instance security group. Okay, want details. Let's give some user data. So I'm launching three instances, and let's see how we can connect with the load balancer. So I created this script. I'm just going to copy this out so that if we need this thing in the upcoming time, so we can copy this notepad. Okay, this is done. So yum update icon y, yum install httpd icon y, this is data start httpd and index httpd echo. This is coming from $hostname icon f, index.html launch. Okay, so go towards instances. If I can just go towards the instance state equals to running. Okay, so we have three instances running, right? So let's wait for these respective instances to execute the bootstrapping. Okay, the script is still not executed. Let's just wait. Okay, this is working. So the things are working fine. So let's head up towards the load balancer. So if you can, in the left hand side, you can see load balancing. Click on load balancers over here, right? So we cannot find any respective load balancers over here. Click on create load balancer. So you can see different load balancers available: application load balancer, network load balancer, gateway load balancer. Right. On the other hand, we have classic load balancer as well, which is almost going to deprecate, and soon this will not be available over here. Right. So let's create the classic load balancer first, so that you will get the idea that how the things are actually working. Click on create. Right. So a load balancer name, let's say classic hyphen load balance. All right. So this is respective load balancer. I'm just giving the classic load balancer name. Click on security groups, right? So I'm creating a new security group, classic load balancer LG as SG. Okay. So our custom TCP respective port range is 80 from everywhere is allowed. Okay. So this is saying that load balancer is not secure. I know that. I'll check. Okay. So here is the important thing which we need to check on. This is the concept which health check I was explaining in the theoretical concept. So as you can see, the load balancer will automatically perform the health checks on EC2 instances. The EC2 instances should pass the health check, so in order to be available in the healthy mode. So if the health check fails, automatically removed from the load balancer, right? So as you can see, response timeout simply means that means let's say if the respective instance is unhealthy, after how much amount of seconds the request is called timed out, right? In the how many interval amount, let's say if we need to check in every 30 seconds, every 20 seconds, or every 10 seconds, that is the interval in which we need to check the instances. Unhealthy threshold simply means in how much amount of time, let's say if we have an instance we have checked twice, right? That means that respective instance is still not responding. That means we can mark that respective instance unhealthy. On the other hand, healthy threshold simply means and means number of consecutive calls to mark the instance healthy, right? So the thing over here is, so click on add EC2 instances. Right now, I'm just adding all my 3 EC2 instances into the classic load balancer attacks. Don't want to add any tags, we can create. Create. Close. So this is just for the illustration purposes. And in the thing over here is we just need to check on the respective CIDRs for to which respective people to allow. But most of the time, we just need to be available on the respective CIDR ranges for the load balancers as well. But just for the illustration purposes, we are just the security group is available. So right now, this is the outer service. So refresh this page. Description. Okay. So if I can just copy the DNS name of this respective load balancer, which is a type A record. So copy this out, and move open the incognito tab here. Yeah. Okay, so let's zoom in. As you can see, if I just refresh this page, you can see the load is balanced across the three nodes or the three instances at the backend. Right? If I just hitting the refresh button, you can see this is the classic load balancer is sending the load to different available instances at the backend, right? But in the different load balancers available, that is application load balancer and everything, we get much more flexibility. What is the extra facility or flexibility which we will get? We will see this thing in the upcoming hands-on part. Let's close this out, and I'm going to delete this particular load balancer and delete this, delete. So the classic load balancer is now completed, right? So now let's head up towards one more theoretical concept for the application load balancer, right? So in the application load balancer ALB, which works on layer 7, right? What is the meaning of real 7? That means HTTP, right? So load balancing is handled across the different machines, and in those respective machines are available in something that is known as target groups. Okay, we can also choose containers or lambda functions to manage the load, right? So let's say if in the target groups, let's say if this is the target group 1, TG1, and let's say this is TG2, right? And here is our load balancer over here, right? So the thing over here is, let's say this is the load balancer, right? And we need to deploy our instances in different target groups. Let's say I've given 2 instances in this target group and 2 instances in this target group. So why different target groups are available over here, right? So let's take this as scenario. Let's say this is our load balancer, okay, and this is one target group in which 2 instances are deployed. This is another target group in which 2 instances are deployed. LB, TG1, TG2. Okay. So the thing over here is, let's say I uh, I just need to submit something. Okay. So let's say I just need to post something. There's one route that is known as, let's say, post, right? So in the end, I can route my traffic to target group 1. If I need to search something, let's say /search, let's say, I can route my traffic to target group 2. If I just need, let's say, some kind of a payment or something like that, I need to make payment or something like that, I can create a dedicated payment gateway, which is handling at the backend, let's say TG3. So I can just make another route that is payment, and I can route the payment traffic. Yes. So that is the power of the target groups, which is available in the application load balancer. Application load balancer is a great fit for microservices, that is container-based applications, Docker or Amazon Elastic Container Service as well. That means obviously in the ECS, if you have ever worked with Docker before or ECS before, application load balancer has a port mapping feature to redirect the dynamic port in Elastic Container Service as well. Right? So now let's head up towards the concept for the application load balancer. But the thing over here is, you need to remember this thing. Okay. So let's say this is the client. Okay. And between this is the load balancer LB. And this is the EC2 instance where application is running. Okay. The client IP has some XXXX IP. Okay. And in between, there's something that is known as connection termination, which will happen. Right. So the request will be thrown to the instance using the private IP of the load balancer. If you need the IP of the client, you need to check the headers which are coming from the client, right? That means you need to check the network tag, and you need to check the headers. That means there is something that is known as X forwarded proto, and there's one more proto that is known as by which you can directly check the IP of the client. But remember one thing: client will send the data to the request to the load balancer. Connection termination will happen at the backend, and the private IP, the load balancer's private IP, will send the traffic to the EC2 instance. If you need the IP or the or details for the client, you need to check the headers, right? This is just for the knowledge purposes. Let's head up towards the application load balancer. Okay, so go towards the load balancers over here. Okay, create load balancer and application load balancer, which works on HTTP and HTTPS traffic. Okay, create load balancer name. Let's say application. Just a second. Application hyphen load hyphen balancer. Okay, this will be internet facing. Okay, and IPv4 and diverse stack means that means IPv4 and IPv6 both are allowed, but I'm just going with the IPv4. What is the meaning of IPv4? You don't need to remember this right now. Okay, so right now I'm in the Mumbai region, so I'm just selecting all the respective availability zones, and my load balancer will be available, right? Remember one thing: the IP will be assigned by AWS. This much more flexibility will be available in the network load balancer. Security groups. Okay, so there's one more thing which we need to understand at the security group level. Right now, I'm just going to create a brand new security group for our load balancer. Okay, so security group name, let's say application hyphen load hyphen balancer. Okay, inbound rules, add rule, let's say HTTP traffic will be forwarded from anywhere, obviously, right? Outbound traffic is allowed, so create a security group. Okay, ALBSG, application load balancer security group, create a security group. The security group is now created, so I'll attach this respective security group. Application load balancer security group, here it is. So I have attached this respective one. What does meaning of listeners? We will see this thing in a much more deep dive. Right now, I'm just going to create one target group, right? To create a target group. Okay. So right now, we can select a specific target, instances, IP addresses, Lambda functions, and application load balancer. Right now, we are just working with the application, sorry, the instances. So target group name, let's say app hyphen target one. Okay. HTTP port 80, right? And protocol version will be HTTP1. Health checks on this respective path. Okay. So tags are optional. So let's click on next. So I'm just selecting all the three instances over here, or we can select two or one instances as well according to the use case. Click on include as pending below. That means we are including the respective instances into the load balancer, create a target group. An HTTP port is open because obviously this is the web application, so that is why this is open, right? So HTTP port works on port number 80. I'm not opening port number 22 to SSH. So obviously this is the basic thing which you need to know. That is why I opened the port number HTTP 80 to access the web application, not my instances. Load balancers. Click on the load balancer. Target group. Target group is created. App target one. I just selected this one, and nothing is as such required over here, right? Create the load balancer. Okay, so use the load balancer over here. This is still showing the old UI. I don't know why. This is provisioning. This should show the new UI. I don't know why this is showing the old one. Let's wait for the instance to get provision. If we check the target groups over here, this one, targets, this is initializing. Okay, as you can see, the health is healthy. If I just go towards the load balancers again, this is active, and click on the DNS name, copy the DNS name. Okay, as you can see, this is routing the traffic with to the different respective uh, nodes or instances at the backend. Okay, so this is the thing which we can uh, connect on. Okay, so right now, please remember this. I've opened the port number 80 just to access the web application. Port number 22 is not open, right? So nothing. Obviously, the port number 80 is open, and we are not using any SSL or TLS at the backend just to so that we need to work on HTTPS that works on port number 33. 443. So accordingly, we just need to use the certificates if you need much more security, right? So if let's move ahead with the a little bit deeper concept. So if you need to route the traffic to a specific route, right? So you can see listeners over here, right? So right now, if I can just click on this one, click on this listener ID, right? So if I can click on rules over here, if I can click on manage rules, so this is some kind of a if else condition. So if, right, so if I can click on this, we can insert a rule. Let's say the condition, and then what will happen. So if the, let's say, different options are available: host header, HTTP header, or query string, or source IP. So right now, if, let's say, if the path, let's say, is let's say slash error. Okay, so what you need to do is click on add action. We can forward to some specific target group, or I can redirect to some specific path, or what I can do is I can return a fixed response as well. Okay, so let's say if someone will hit at this respective path slash error, a fixed response will be returned. Let's, so I can just type on fixed response that this is error page. Okay, so I can you can see if the path will be slash error, the fixed response, the 503 status will be returned that this is the error page. You can save this out, right? So remember one thing: 5xx means application induced, and 4xx means client induced errors. So if I can just go back towards my load balancer, right? Description, copy the DNS name over here, copy. If I can just type slash error, you can see this is the error page because I have automatically redirected to, I just typed slash error over here and I have redirected to the fixed response. This is the error page, right? So this is the thing which you can, you also have the flexibility to edit in the respective um, application load balancer as well, right? So this is the four concepts for the application load balancer, right? So I can just delete this load balancer again. Okay, so let's not delete this because I think this should be available required in the auto scaling group section. But okay, we'll create a new one for the same. So if I delete this one, delete application load balancer is now deleted. Okay, so the load balancer is now deleted. So if I can again go towards the create load balancer, right? So now the concept available for the network load balancer, NLB, right? Please remember this thing that network load balancer is not available in the AWS free tier, right? So AWS free tier network load balancer is not available in the AWS free tier range. So NLB works on layer 4, okay, which is the network load balancer will forward the traffic, the TCP and UDP traffic to your respective instances. It can handle millions and millions of requests per second. It has very low latency, that means around 100 ms. It means as compared to the application load balancer type. In the NLB, we have one more flexibility. NLB has one static IP per availability zone and also supports assigning the elastic IP. Elastic IP simply means one fixed static IP. Okay, that means let's say if your instance is terminating and you're just let's say starting or stopping the instance or rebooting the instance, the public IP is changing. What you can do is you can use the elastic IP, and AWS account will provide 5 elastic IPs per account. And if you want to increase that, you need to contact the AWS support for the same, right? So NLB is used for extreme performance, TCP or UDP traffic. And please remember that NLB is not available in the AWS free tier, right? So this is the thing which we need to remember, right? So right now, as the NLB is available, not available in the AWS free tier, right? So what you need to do is we are not just going to perform the hands-on for the same, right? So it will cost you a little amount of money, right? So NLB thing, please remember that this is exactly the same, but this is available for the high throughput and high network performance, right? So now let's head up towards the new concept or new load balancer that is known as gateway load balancer. Still, this is not available in the AWS PTA, right? So gateway load balancer. Okay, gateway load balancer. Let's say directly just make the diagram for this. Let's say if we have the users, right? If we have different users available over here, right? So let's say there is one gateway load balancer available in the between, right? And there's one application available over here. This is one gateway load balancer available over here, right? So please remember this. In the gateway load balancer, the traffic will be transferred to the load balancer first, right? And this is the one target group available at the backend. Here, some third-party virtual security appliances are running at the backend just to handle the security, right? And the traffic will be sent to these respective third-party security virtual appliances, and the traffic will be analyzed. That means the some kind of fraud problems or prevention or deep packet inspection or payload or something like that, which where we need to monitor each and every bit. And these respective things will be analyzed. And if the traffic will be fine, it will be sent back to the load balancer, right? And in the end, if that traffic is not that much acceptable or something is not good, the packets will be dropped. And if the things are going well, we can send the traffic to the application. So this is very, very, very complex to configure. So here at the users level, we have some kind of a route tables available. Okay, route table available just to uh, route the traffic to the uh, gateway load balancer. So this is much more towards the VPC side. We are not going to cover VPC at this point. Okay, so gateway load balancer works at the layer 3, that is network layer. I'm not going to explain what is the meaning of network layer. So, so transparent network gateway, that is single exit and entry for all the respective traffic, and the load balancer will distribute the traffic to all the virtual appliances, right? So this respective gateway load balancer use GNEVE protocol, GENEVE protocol, which works on port number 6081, another common interview question. Right? So if the things will work, right? So GDB protocol and 6081. So this is the uh, core concept for the gateway load balancer, right? So this is very tough to configure, right? So this is the thing which we need to just understand the concept if you are just preparing for some AWS exam as well, right? So this is the 10,000 feet overview for the same, right? So let's head up towards another concept. I think something is missing in the application load balancer side. Uh, okay, something is not get covered. I think these sticky sessions. Just a second. So if I just go to the target groups, just a second. If the targets are unused, okay. So I'm just going to create a one more application load balancer. Create load balancer. Application load balancer. Create. What is the meaning of sticky session? We will see just a second. Internet facing IPv4 and in all the respective regions. I'm just going to select the security group. Okay, target group, this one, and create the load balancer. This is provisioning. Let's wait. Okay, so in the meantime, this is provisioning. Let's understand the concept of something that is known as sticky sessions. Okay, sticky sessions, or something that is known as session affinity. So what we can do is sticky session is just to maintain. Okay, the most best use case is just to maintain this session for the different available users who are using their respective application. The cookie is used for stickiness and has an expiration date which you can control, obviously, right? So let's say if you have let's say 3 users available over here, right, and there's one application load balancer available over here, two EC2 instances available here. Okay, so now what you need to do is, let's say if the people are accessing your respective application, this one is accessing this one, like this, right? So what you can do is, by maintaining this stickiness or session affinity, you can just send the traffic to the defined EC2 instance only, right? So the cookie is used for stickiness. Obviously, we have the control for the expiration date as well, and enabling the stickiness may bring the imbalance to the load balancer. So obviously, this is only the use case is to maintain the sessions for the sticky using the sticky sessions or the session affinity. Session simply means that means the user logged in data or something like that, right? So there are two types of cookies: the application based cookies and the duration based cookies. So I'm just going to write over here so that you can remember the same: application based cookie or duration based cookie. Okay. So in the application based cookie, we have some custom cookie which is generated by the target, and obviously it can include any custom attributes and required by the application, right? On the other hand, we have another subpart that is known as application cookie, which is generated by the load balancer, and the cookie name is defined, which you cannot use. That is AWS ALB app. On the other hand, we have duration based cookies over here, the second one, which is cookie generated by the load balancer. and there are some defined and reserved names which you cannot use at the cookie names, that is AWS ALB or AWS ELB for the classic load balancer. So you need to remember this thing for the sticky session thing. So if I just check the status of the load balancer, this is active right now. So what I need to do is just head up towards the security, the security group of the EC2 instances. Let me show you something. Instances. This one, security, and if I just go towards the security group here, added then one rules. So as you can see, the HTTP traffic is coming from anywhere, obviously. So I'm just restricting this traffic from this traffic will be hit from the application's load balancer only, not from everywhere for the EC2 instances level. So application load balancer, right? Let's delete this one. So add a rule HTTP. Application load balancer SG, right? Save the rules. Okay, so this is the thing which is required to maintain another layer of security, right? So this is the thing which we can use. Let's say right now what I did is, so here, as you were already aware that I have created a security group where the instances security group are open for port number 80, port number 80, port number 80, port number 80, and for the application load balancer as well, I have opened the port number 80, right? But right now I don't want anyone to access my instances directly, right? So I have just deleted the port number 80 to direct access. So I have applied the security group ID for the application load balancer on these respective instances. That means the security group which is attached to this respective application load balancer, that means the ID is used on in the security group of these two instances. That means nobody will be able to access the instances directly. They need to hit the respective load balancer first, and the traffic will be forwarded directly towards the EC2 instances. So this is some another layer of security, and this is the best practice used in the real world as well, right? So if I just go over here, security groups, so you can see the application load balancer in one rules. So as you can see, HTTP 80 is allowed from everywhere, but if you can see for the instances security group, instances G, the traffic is allowed only from the security group ID of the application load balancer, right? I hope the things are clear. So if I just go towards the load balancer again, load balancers over here. As you can see, we are able to access the application from the load balancer. If I just head up towards the instances again and try to access the instance directly, let's see what will happen. Copy the public IP, copy, paste it over here. Now we are not able to access. Why? Because directly the access of EC2 instance is now closed, right? So this is the another layer of security which you need to use, right? So close this out. Now let's see the sticky session. I just need to maintain the session. So if I just go towards the target group, right? Target group one, this one, click on actions, right? So here, if I can just click on the add the target group attributes, go down, you can see stickiness over here. So as I already conveyed, the application based cookies and the load balancer generated cookies we have discussed in the theoretical concept, right? So here we can see application based cookie, you need to give the name of the cookie, or the load balancer generated cookie which is generated by the load balancer. you can maintain the stickiness for 1 day to 7 days. Obviously, this is the range is 1 second to 7 days, but we can configure according to our use case. So I have just enabled the stickiness, and let's see how our load balancer response will behave. So save the changes. So the changes have been saved. If we go towards the load balancer again, copy the DNS name, this one. Okay, so this is the, if I can just refresh this page, I can see I got sticked to one respective instance. I'm getting the response from one instance only. I'm just refreshing this page many times. Stickiness is enabled over here. This is the common exam question for AWS Certified Solutions Architect Associate, as well as AWS Certified Developer Associate as well, right? So right now I'm just going to going towards the target group, actions, add target attributes. I'm just disabling the stickiness right now again and save the changes. Okay, so this is the thing regarding the load balancer part. We have learned classic load balancer, application load balancer, network load balancer, and the concept of gateway load balancer as well, right? So this is the thing which you need to remember, that how the things are actually handled at the backend. On the other hand, please remember the security group concepts which we have learned. That means we have applied some additional layer of security so that no one will be able to access the instances directly without hitting mm, the DNS name for the ALB, right? So this is the power of the load balancing. So the last part of this session today is for the auto scaling groups, or ASG, okay? Auto scaling groups, right? So auto scaling groups, let's say in the real life, the load on your websites obviously can change dynamically, right? So in the cloud, you can create and get rid of servers very quickly, right? So the primary goal of the auto scaling group is to scale out the EC2 instances to match the increased loads, or remove the EC2 instances to match the decreased load, right? So that means automatically register the targets to the application load balancer, recreate the instances or delete the instances, everything. So this is the concept of auto scaling groups. So auto scaling group is in general free, but you need to pay for the underlying EC2 instances which you are using at the backend, right? So there are some terminologies available for the auto scaling groups, right? So let's say if we have this auto scaling group available over here, this one, okay? So I'm just writing over here, auto scaling group. Okay, so we have EC2 instances available over here, this one, this one, this one, and this one, right? So there is something that is known as minimum capacity. That means the minimum amount of instances you want always to be available, minimum capacity. The second one is desired capacity. Okay, so let's say this one is the minimum capacity. This one covering this one is a desired capacity, right? And the maximum capacity, that means how much amount of instances can scale up. Let's say we can scale out. It means we can add how many amount of instances. Obviously, we have a limit. So let's say if you have settled the maximum capacity to 10, right? So that is the concept of maximum capacity. Okay. So this is the basic terminologies of the uh, auto scaling group. So for creating the auto scaling group, you need to use something that is known as launch template. Okay, launch template. That means you need to. That means sometimes some type of a configuration which you need to give. That means the auto scaling group can create the instances automatically according to the given configurations, right? So let's directly head up to the auto scaling group section. If I can just go and go towards the auto scaling group over here. So in the end, click on create auto scaling group. Let's say uh, just a second, auto scaling group. Okay. So now we need to create a launch template over here. Okay. So let's say ASG hyphen template. Okay. So right now, let's go in the quick start. So I'm just going to the Amazon Linux 2. Again, the instance FSP2 micro. Uh, Here I'm just going to select a T2.micro, which is available in the free tier. Okay. And the key pair login. So I can just give the specific key pair. Let's say uh, this key pair. I can give, right? On the other hand, uh, the security group. I can give the security group, let's say any specific security group. You can use security group and give the security group as well. So what I can do is I can just create a new security group completely for the ASG. Okay, auto scaling group for the ASG. So if I can just click on rule, HTTP, okay, port 80, custom, let's say anywhere, application will be accessed, right? I don't want any specific EBS volumes. Uh, so let's see if anything else is left. Click on advanced details. If I can just provide the user data as well, let's say copy this one. Okay. So create the launch template over here. Okay, description is required. ASG description, ASG configuration. Okay, launch template. The launch template is now created. So I can go over here, refresh this. You can see ASG template. This is the summary, right? The security group and ASG template and everything. Next, VPC availability zones. Let's say A, B, and C. We can do accordingly, right? So we can also override the launch template, but this is completely out of scope. Click on next. Okay, health checks. Right now we can also attach the existing load balancer, right? Target groups. I'm just selecting the target group which is attached to the application load balancer, TG1, right? The health checks. This is exactly the same thing. Remember this thing, the EC2 health check is already pre-checked. Obviously, the EC2 instance will be checked at the backend, right? We can also enable the ELB health check as well. We want monitoring. We don't want any specific CloudWatch. So click on next. We will see this thing in the in just a minute. So I'm just going to select next, next, and next. Just a second. Let's stop the instances which if something is running at the backend. That I can just show you the power of the auto scaling groups. So let's instance state, terminate the instances, terminate. So I'm just terminating the instances which are handled by the load balancer so that auto scaling group can create those instances automatically, correct? Terminating. As you can see, there are no asset instances which are running. So review this. I think this will be the EC2 instance page. Okay. So if I can just create auto scaling group, the auto scaling group is created successfully. Click on this, and you can see the desired capacity, union capacity, and maximum capacity over here. If you go on activity, you can go on activity history. You can see this is launching a new EC2 instance for us because at least one EC2 instance should be there. As you can see, the minimum capacity is 1. At least one should be there. So if I can just refresh this, you can see this is launched by the automatically by the auto scaling group. If I can just click on this, click on tags, you can see this is launched by auto scaling group, right? So this is the thing. You can see the logs or the details or the events, right, in the activity history of the auto scaling group section, right? So if you can just refresh this, you can see success. So let's play. Okay, so if I can click on details, click on let's say edit. Now I want let's say desired capacity, let's say to be 2, and the maximum capacity, let's say I want 3. Okay, so update. Okay, so now let's see in the activity. So click refresh this. It will soon launch another EC2 instance for us. Okay, so you can see the auto scaling group is launching another EC2 instance for us, right? So you can see this in the activity history. If I can go in the EC2 console, you can see this thing. Okay, you can see 2 instances are now running by the our beloved EC2 instance. Sorry, our beloved auto scaling group, right? So this is a thing which you need to remember. In the activity history, you can see this, right? So again, now this is somewhat a manual work. I want complete auto scaling, right? That means basically the name is auto scaling. So why the automatic scaling is not there, right? So somewhat we need over here, right? So let's understand some theoretical concepts before directly jumping towards the completely automatic scaling thing, right? So if we can see this, so auto scaling can be configured using the CloudWatch alarms as well, right? So what is the meaning of CloudWatch? Something like that. Let's say if you uh, there are some CloudWatch metrics available, let's say which is monitoring the CPU, networking, network out, let's say JVM or anything. That means we can use some respective alarms. That respective alarm will get triggered, right? And accordingly, the respective the auto scaling group will react, right? Let's say if the CPU utilization of the instances is spiked to 80%, we need more instances now. Auto scaling group will instance, let's say, will add 2 instances automatically. Let's say I want, let's say if the CPU utilization is below 40%, okay, so sorry, below 40%, so you can reduce 2 instances. So this is the thing which we can, such policies or which we can use accordingly in the auto scaling groups, right? So there is something that is known as dynamic scaling policies, right? This is the question which is also being asked in the solution architect associate examination as well. Dynamic scaling policies. Okay, So there is something that is known as target tracking policy. There are three types of policy: target tracking. Another one is simple or step scaling. Third one is scheduled. Okay. So target tracking means this is the most easy one and easy to set up. Let's say if the I just want let's take an example for this. Let's say I just want the CPU utilization of the autoscaling group to be always available around 40% only. If this is increasing, scale out the instance. Okay. Simple or step scaling simply means that means we can set up the CloudWatch alarm. Let's say if the CPU utilization is, let's say, greater than 70%, right? So we need to add two instances, right? Let's say if the CPU utilization is less than 30%, so we need to remove two instances. Okay. Scheduled action simply means, let's say, I have something scheduled, right? Let's say if something is scheduled on, let's say, Friday, 10 a.m., right? Great amount of load will be thrown on our application, right? So that we can schedule the scaling accordingly, right? So there is something that is known as predictive scaling, which is more inclined towards the machine learning. Predictive scaling. Predictive scaling means this is continuously forecast load and scheduled scaling ahead, right? So let's say you need to analyze the historical data, right? Let's say if you have some analyze of some previous historical data, let's say that the load is coming in this month on when the new product is launched, whatever it is, right? So you need to predict the load according to the previous data, and you need to scale the instances accordingly, right? So the CPU utilization and the request per count and average network in and out are mostly used, okay, CloudWatch metrics in the auto scaling group concept, right? So another last theoretical concept available regarding the auto scaling group is cooldown, right? Cooldown. Cooldown simply means what? That means after any specific scaling activity happens, that means there is one cooldown period of 300 seconds. That means 5 minutes. Okay. So during the cooldown period, the auto scaling group will not launch or terminate any additional specific instance. Remember this. Cooldown period is of 300 seconds or 5 minutes. During this cooldown period, the auto scaling group will not launch or terminate any additional specific instances, just to allow the respective CloudWatch metrics to get stabilized, right? So obviously the CloudWatch metrics will take 5 minutes to get completely stabilized, right? So let's see this thing in action. So I'm just going towards the details and added this out, and I'm just going to the maximum capacity, let's say 4 update. Okay, automatic scaling. Right now, as we have seen the scheduled actions and predictive scaling, right? I'm just going towards the dynamic scaling policies. Create dynamic scaling policy. Right now, it is going towards the target tracking or step scaling. Let's say in the step scaling, we can set the CloudWatch alarms or policy name which we can give, and the action which we can take is add the capacity units. Let's say one capacity unit or whatever. Simple scaling, the same thing. That means the CloudWatch alarm which we can add, and the action which we can perform, add, remove, or we can also perform the set to operations in this case. So let's go towards the target tracking scaling. So average CPU, let's select the target value, let's say 40%, right? So so and let's say if the CPU utilization will hit the 40%, automatically the instances will be created. Okay. So right now I'm just going to give some stress to my EC2 instances so that the auto scaling can happen. So I don't exactly remember the security group. I have given the one rules. Okay, add rule SSH. Okay, from my IP only. Save the rules. Okay. So I'm just going to copy this public IP, close this out. Okay, so just going over here. What happened? Okay, sorry, EC2-user. Okay, right now I'm in the EC2 instance. So let's give some stress to our EC2 instance so the CPU utilization will increase. So if you need to give the stress, so search AWS, Amazon, Linux to stress. Okay, so I can just go towards this GitHub. So I'm just installing this respective software, the stress software to give some stress to my instance. So let's install this respective software now. I just configure the repository. So install the software now. So this will hit some stress on my EC2 instance. So stress -c, let's say 40. So in this thing, we will just use 40 virtual CPUs in this thing so that we can hit the respective stress in this case. So let's see how our instance is now behaving. So if I can just go towards the auto scaling group and auto scaling group over here, activity and monitoring, click on EC2. Let's wait for the CPU utilization to shoot up. Okay, 46%. It is just stressed. It is highly stressed, 46%. And let's see the activity. If the instances are being added automatically or not, if it is free. Soon it will launch an instance. Let's see the CPU of this respective instance. It could drop 66 to 0. Sorry, this is the one. So if I can check the monitoring, 45 is triggered. Monitoring in this. I think I'm going to set a desired capacity to 3 maybe so that it can automate it check on this out. So update this one activity. We can go on monitoring EC2 58%. A user requested the auto constraints minimum one, maximum 4 desired free, changing desired capacity 1 2 3, and she was started in response. Okay. I just triggered this thing manually. So that is why this is just complaining. But right now, this is launching right now automatically. So just this is giving us the complaint. No problem with that. So as the CPU is bursting out, this will launch the EC2 instance. We can go towards monitoring EC2 56.1%. If you can open this thing in the CloudWatch metrics as well, in the metrics. The CPU utilization should be checked at the maximum. If you click on 1 hour, if you can zoom in this, okay, so you can see it is now 100%. Okay, if we can just go towards the activity, I just triggered the capacity or manually. This is why it is showing the error, but instances can go over here. 3 instances are normal. Okay, so due to the stress, we are just working accordingly here. So the instance is now being launched, right? So the stress is thrown on the CloudWatch, and accordingly the things are being triggered, right? So I hope the things are now clear. So I can just reboot the instance, so the things will get synced up. Reboot instance. Okay, this instance is now rebooted. This is now running, and this will the CloudWatch metrics will come down to the CPU utilization. Okay. So if I can just go towards the auto scaling groups, you can see if you can just click on the desired capacity as if auto scaling group service is free, we are just need to pay for the underlying EC2 instances. If I can just set them to 0, everything will be deleted. You can update the things, automatically the auto scaling group will just set the things to 0. Right. So this is the core concept regarding the auto scaling groups. Right. Automatically these respective instances got deleted. Right. All right then. So we've covered a lot today. We have learned the basics of AWS, why the cloud and what and why the cloud is required. IAM, the IAM users, groups, policy inheritance. We have already also seen the breakdown of the JSON policies, right? And we have seen the IAM roles as well. And the on the other hand, we have also synced up with the real policy and breakdown of the policy. We have understood EC2 instances. We have already seen that what the EC2, the concept, the theoretical concepts, and the bootstrapping and user data, Hibernate,
EBS snapshots and load balancer, classic load balancers, application network, and the gateway load balancer as well, auto scaling groups. So I think the things are gone well. So we are at the end of the session now. So I hope you understood the concept. So thank you so much for attending this respective session. Please take care.